This is Algebra 2 at Trig, Unit 6, Semester 2 exam review. So we're looking here at f of x equals 3 times a half x, half to the x, minus 5. We're trying to determine what's happening here. Well, our ratio is a half, and that's dropping down. So it's getting smaller and smaller over time. The 3 just does a vertical stretch, so that doesn't overly affect the graph. It just takes every y value and times it by 3, but it's still going to approach 0 as we go. So it's still going to look like that. So this graph here would look more like 3 half to the x. Now, the negative 5 is a big deal because it's going to bring the graph down to 5 down here. So your domain is going to remain the same. What values can you plug in for x? And you can plug in all the numbers for x. So the only reasonable answers are B and D. Negative 5 is our smallest number, and it goes up after that. So D would be our answer. It's not infinity to negative 5. It's negative 5 to infinity, the correct order. You always put the smaller number first. Identify the equation that would be used. Suppose you deposit $2,000. Every one of these has $2,000 being deposited. So find the balance after 5 years. That's 5 years, 5 years. Every one of them is timesing by 5. So that's not changing. If the bank account pays 2.5%, that's going to be 0.025. So that's going to rule this one out because that's not 0.25. This is a possibility. This is theoretically a possibility. And this would be a possibility. Interest compounded monthly. Being divided by 12 is appropriate, so this is still good. This is being compounded continuously, so this is out. This is being compounded monthly, but this value here should be a 12. We should be using A equals P, 1 plus R over N, N times T. That's our formula. You probably want this on your note card. So that looks like our best choice. So what I did is I went through each of these questions and I found out the part that didn't work. This was compounded continuously. This had the wrong value up next to the years, and this had the wrong interest rate. Number 3, identify the domain in the range. Well, a logarithm. What we know about a logarithm is a logarithm basically looks like this, where you cannot take the log of 0. You cannot take a log of a negative number. But we can move it to the right. That's moving it to the right 3. So what's going to happen is we go 1, 2, 3, and it approaches that asymptote. Give that asymptote here at positive 3. It's always the opposite of what you see. My graph kind of implies that it was higher. It's not trying to be higher. It's just coming across. So it's not all real numbers because we're limited on what x values we can do. So we're going from 3 and going bigger. You can take the log of 0, but you cannot take the log of a negative number. You can't take a log besides that line. So this is being okay in all real numbers. I see the answer as being C. Evaluate the expression. Here we have log base 2 of a fourth. So 2 to what power gives you a fourth is really what's being asked. 2 to what power gives you a fourth? Well, since we're making a fraction out of it, you know it's going to be negative, and it's got to be negative squared. So 2 to the negative squared gives you 1/4. 1/4 is 1/4. So negative 2 is the value that this is. Because 2 to what power gives you 1/4, it has to be a negative 2. The negative puts it into the denominator, the 2 squares the base of 2. Identify the transformations that took place. We have a vertical stretch by a factor of 2. And we're translated to the left 3 and down 4. So being able to read the equation. The goal isn't to write out these words. The goal is to understand why and how do you know it's a vertical stretch, and how do you know it's a factor of 2, and how do you know it's translated to the left, and how do you know it's translated down. You should be able to look at your equation to determine that. Find the inverse. Okay, well, to find the inverse, first we write it with y. Then we switch the x and the y. Now, we don't need a logarithm if the x is not part of the logarithm. So we're able to turn this back into exponential. So we need to know what the base of this logarithm is. Can anybody tell me the base of the logarithm? It's not written, so it's called the common log, which is 10. So the base is 10 to the exponent, because a logarithm equals the exponent, of 3y minus 1. So this is 10 to the x power. So we're going to add the 1 across. And then we're going to divide by 3. Or I would like to think about it as multiply by 1/3. So I guess in terms of what they're doing, it would be right here. It would be that 10 to the x power plus 1 divided by 3. Find the inverse. Okay, we do it again. So, what would you do? You've got to think about this on your own. So what's our next step going to be? Switching our x and the y.
Does it become 4x, or does the x just become 4?
So now we're going to subtract the 5 across. Now we just have a logarithm. So to get into this logarithm, I have a base with an exponent of x minus 5, because the logarithm equals an exponent. So this is 4 to the x minus 5 power equals y minus 1. So 4x minus 5 plus 1 equals y. And a lot of times we would like to write that as f negative 1 of x. All right. Okay, here's another find the inverse. So we find the inverse by starting with writing f of x as y. I'm going to move my, I got to switch my x and the y. I add my 8. I got to get y by itself. So to solve for an exponent, I need to use a logarithm. What logarithm am I going to use? Natural log, ln. So natural log, you know that the logarithm is going to equal the exponent. So that's y plus 1, natural log of x plus 8. And then we subtract the 1 over. So our inverse is going to be the natural log of x plus 8 minus 1. To graph, we're not going to graph that. We're going to graph y equals log base 3 of x. That's what we're going to graph. And then we're going to translate to figure out that one. So we have 2 graphs to do. 1 table, but 2 graphs. To graph this, we want to write this in exponential form. So the base is 3. So this is 3 to the y power equals x. You know that a logarithm equals the exponent. These are not inverses of each other. This is exactly the way that it's written. It's just an exponential form. So we make our table. Normally, we pick values of x, and then we calculate values of y. But in this case, we don't want to pick values of x and try to find a y that's going to get there. We're just going to pick values of y. Normal values of y that are good to pick be like -1, 0, 1, 2. So what happens when y is -1? A negative exponent, 3 to the -1 power, gives you 1/3. So when x is 1/3, I'm down here at -1. 3 to the 0 power is 1. So when x is 1, I'm at 0. 3 to the first power is 3. So when I'm out here at 3, I'm up at 1. And 3 to the second power is 9. So I'm up there at 9. So there's my graph. Y equals log base 3 of x. So now we're going to take our parent function and translate it. Translate 2 units left, 3 units up. So you take every one of these points and go 2 units left and 3 units up. 2 units left, 3 units. 2, 3. 2, 3. So that means the asymptote that we are approaching comes right here. And that's y equals log base 3 of x plus 2, which makes it go to the left, and plus 3, which makes it go up. So my domain is greater than 3. X is greater than 3. My range is all real numbers. The asymptote is, oh, it's not 3, it's 2. Sorry, thanks. My asymptote is 2. The translating up doesn't affect the range. It goes down forever and it slowly goes up forever.
Wait, what makes it 2? Yeah, negative.
Correct. It is greater than negative 2. The asymptote is at negative 2. Of course. Good call. We should label that. X equals negative 2. I'm pointing to negative 2. I drew negative 2. It's going to be negative 2. Okay, condensing. This has multiple logarithms. We're going to write it as a single logarithm. Some people get confused when you have minuses and pluses. Just be sure you work left to right. The minus tells you that you're going to have log of x over y plus log of z. And when you multiply a fraction times another number, that would go on top. So when you're adding, that's going to go up on top. So my answer should be log xz over y. The yz don't both go to the denominator unless there are parentheses around it. And in that case, you would distribute the negative, and they would both be negative, telling you that both the y and the z were in the denominator. So it's not that. Condensing. We're going to bring the 3 up on top of the x. We're adding 2 logarithms that have the same base. So to add that together, we are going to multiply what we're taking the log of. So this should be log 3x cubed. That should be C. Which of the statements are not correct? When you're adding, you're going to multiply, so that's 48. That would be 16 times 3, which is 48. This is 8 times 6, which is 48. And this is 8 times 3 squared, which is 9. That's 72. So it looks like this one is not correct. These all work. Do we see why this isn't right? This is log of 3 plus log base 3 of 3 squared. This is log base 3 of 8 plus log base 3 of 9. So we multiply and get log base 3 of 72. That's not 48. This is not correct. Which of the following statements is equivalent? So, in other words, we're going to condense this. So if you have the number in front of the logarithm, you write it as a base, or as an exponent. 2 to the 3rd power.
None of them have, what do you call it?
So this is log, a common log of 9 plus a common log of 8. Don't call that 6. This isn't 2 times 3. This is 2 times 2 times 2. So this is 72 divided by 3. Now this is, that seems to be able to be simplified. 3 goes into 7 2 times with 1 left over, so that should be log of 24. So to solve, we're solving for an exponent. So there's a couple different ways we can look at doing this. We could write this as a logarithm. But what I notice is my base is 5. I can make my 25 a base of 5. Now my bases are the same, so I can set my exponents equal to each other. And I add my 1 across. And I divide by my negative 3. And I get an answer of negative 1. Solve the given exponential equation. Can I write my bases to make them look the same? 3 squared is 9. Then I have 2x plus 7. So that's 9 with an exponent of 2x. So it's still the same problem. My bases are the same. So I have x minus 1 equals 4x plus 14. Subtract my x across. Subtract my 14 across. Divide by 3. I get negative 5. So we're going to solve the logarithmic. This is equaling 8. So we want to figure out what the x is going to be. This is log base 4 of 2x minus 1 plus 6 equals 8. Now we have the logarithm isolated. And we see that the logarithm equals no value of x. If we don't have an x over there, then we don't really need the logarithm. We can write it as 4 squared equals 2x minus 1. We wrote it back in exponential form. This is 16. Add the 1 across. Divide by the 2. We got b. 17 divided by 2 is 8.5. Number 17. Take a look at this. The math isn't hard, but the decision on what to do. Should you say 7 plus 4 is 11? Definitely not. You should move your 7 across. That's not difficult. Now, I could use a logarithm, but like we've been practicing a little bit earlier, I can get 64 to look like a base of 4. Four to the third power is 64. 4 times 4 times 4. So now my 2x minus 5 has to equal my 3 because my bases are the same. Move the 5 across and get 8. Divide by 2 and get 4. Solve the given exponential equation. What are you going to do here? Are you going to say 3 times 5? Call that 15? You're going to need to divide by 3. So 8 divided by 3 going to be 2.66. Our answer is going to be a decimal, so it's okay to use decimals. Can I get my bases the same? Not really. So I have to use a logarithm. Log, this is my base, so base 5 of 2.66, and maybe it'd be better to be exact. This is where 8/3 could come into play. You could use that. And that equals the exponent. So we could use the change of base formula. That's log 8 divided by 3. Got to have that in parentheses. Divided by log of 5. That is 0.6094. That equals x minus 6. So I'm going to add 6 to this and get 6.00. 6.609. Which would be 6.61. Not 6.5. That's not what it is. Now, another thing you can do, just knowing your calculator, I think it's in math. Go over to number. No, go to second y equals, alpha y equals, hang on a second. You can do this through catalog, which is down here above the 0. That's how I usually do it. But there is a menu. If you hit alpha window, you'll find the base formula in here. And you can write your base out. What was that, a base of 5? Of 8 divided by 3. And you'll get that same number we did earlier. I don't know if that's easier. Change the base formula. Whatever. 2 different ways to do it. Alpha F2. And you'll see it there as number 5. Has the base. Number 19. Solve the given logarithmic equation. So what are we going to do here? How do we solve that? What's the first thing we're going to do? What do your algebra rules tell you?
Add 9 to both sides.
We're going to add the 9 over. Then we're going to divide by 2. Don't use this as an exponent. You don't want to make this an exponent of 2. Mathematically you can, but divide by 2. That's 4.5. Now I have a logarithm that does not equal an x value, so I do not need the logarithm, so I'm going to write this as exponential. 3 to this 4.5 is going to equal 2x plus 1. Leaving it as a fraction did not help me. I don't know the square root of 3 and then to the 9th power. That doesn't help me. So in terms of our decimal, 3 to the 4.5 power. Subtract 1. And divide by 2. Number 20. Solve the logarithmic. What do you see? What can you do? I see log base 3 of x plus log base 3 of x minus 6. Is this going to be log base 3 of 2x because it's x plus x? No? What do we do when we add two logs together that have the same base? We just did it. We multiply. Log base 3 of x, x minus 6. We're condensing two logarithms into one logarithm. Now we see the logarithm equals a non-x value, so we don't need the log. So we're going to rewrite this as 3 to the third power equals x squared minus 6x. Then I'm going to bring over the 27. Three to the third power is 27, not 9. Then you have to factor apart what multiplies to be 27 and adds to be 6. One's got to be positive, one's got to be negative. So x equals 9, x equals negative 3. You got to watch this. I think this has come up in the exam before. Is it both answers? Is it one of the answers? Is it none of the answers? So when you come up here, I plug in 9. 3 to what value makes 9? That's possible. Negative 3. Hey, you can't do a log of a negative number. 3 to nothing makes negative 3. So this is the value that doesn't exist. This is extraneous. So that's not a real answer. The only answer is 9. So you get all excited and you say this is your answer. Because you did your math, you showed your work, you did all your calculations. And you're like, I got those two answers. This is extraneous. This is not really an answer. So it's definitely not the answer. Only 9 is the answer. Solve the logarithmic equation. Last one. Natural log is exactly like a normal log. So if you can do the previous problem, you can do this problem. Divide by 3. 12 divided by 3 is 4. What am I going to do from here? This is making those decisions. Mathematically, it's not tough. But if you don't know what to do, you can't do it. How did we turn this logarithm into not a logarithm? So how are we going to turn this logarithm into exponential form?
3 to the power of 12.
Remove the 3 over to make the 4. So now we need to take the base. What is the base of the natural log?
E.
So we have e to the 4th power equals x minus 7. So your calculator has e to the x power right there. So e to the x power is 54. Then we're going to add the 7 across. That equals 61. $61.60. That's Unit 6.